In our previous video, we learned how to find out the square roots of perfect squares, which was part 1 of square roots. This is the part 2 of square roots, where we will learn how to find out square roots of imperfect squares up to a close approximation. It will never be an accurate value, but it will be a very close approximation to the actual value which we will require in competitive exams. A link to the part 1 where we show how to find square roots for perfect squares will be given in the description below. So let's start with this. Suppose we are asked to find out square root of 37, which is an imperfect square. Now, the perfect square nearest to 37 is 36, which is 6 square. Therefore, in order to find out square root 37, we will use this formula where we will use 6, or the square root of the perfect square nearest to 37, that is 6. Fine, it will be an approximation value. 6 plus 37 minus 36 by 2 into root of 36. Here what we are doing is, in order to find out square root of 37, we will take the square root of the perfect square nearest to 37, add it to the number minus its nearest perfect square, and divide it by 2 into square root of the perfect square nearest to the number. Fine, this is going to be the formula. So 6 plus 1 by 2 into 6, which is going to be 6 plus 1 by 12, which is going to be an approximated value of 6.0833. Therefore, our square root of root 37 will have an approximate value of 6.0833. Now suppose we are asked to find out the square root of 29. Now from the table we can see that the perfect square nearest to 29 is 25, which is 5 square. Therefore, the closest approximation of the square root of 29 would be 5 plus 29 minus 25 by 2 into root 25, which would be 5 plus 4 by 2 into 5, which is going to be 5 plus 4 by 10, 5 plus 0.4, 5.4, right? So this will be the closest approximation of the square root of 29. Now let's try it for another number. Now suppose the next number whose square root we are going to find is root of 53. From the table again you can compare and check that the perfect square nearest to 53 is 49, which is 7 square. Therefore, let's find out the closest approximated value of the square root of root 53. Now, square root of 53 will have an approximate value of 7 plus 53 minus 49 by 2 into root 49, right? Which will be 7 plus 4 by 2 into 7, 7 plus 4 by 14, which will have an approximate value of 7 plus 2 by 7, 7.2857. Therefore, the closest approximated square root value of 53 is 7.2857, right? Now let's check it out for some bigger numbers. Now you might be thinking that this way we cannot find out square roots of imperfect squares of very large numbers, right? But that's not so. We can actually find out square roots of imperfect squares of very large numbers too. Suppose you are asked to find out square root of 7600, right? Now what you can do is you can break it up into square root of 76 into square root of 100, which gives us square root of 76 into 10, right? Now let's find out square root of 76 using the method that we used before. Now checking, we find out that the perfect square nearest to 76 is 64. Therefore the perfect square nearest to 76 is 64, which is going to be 8 square. Therefore square root of 76 is going to be 8 plus 76 minus 64 divided by 2 into root of 64, which is going to be 8 plus 12 by 2 into 8, 8 plus 12 by 16, eight plus 0.75, 8.75. Now therefore root of 7600 is going to be 8.75 into 10, which is going to be 87.5. So here we have the approximated value, or the closest approximation of the value of square root of 7600. This way we can find out square roots of imperfect squares of very large numbers as well, by breaking them up into combinations or multiplications of imperfect squares and perfect squares. Now we'll learn a new method of finding out square roots of perfect squares greater than 40,000. In the part 1 video we had learned how to find out square roots of numbers which were perfect squares that were as great as 40,000, right? But here we will learn how to find out square roots of numbers that will be greater than 40,000. Now there's a different method for that. Let's learn it. Suppose we are asked to find out square root of 537289. What we do is we break up the number into pairs of 2 starting from right. So 537289, this is one pair, this is one pair, and this is another pair, gives us 89, gives us 72, gives us 53. This is our first pair, this is our second pair, and this is our third pair. Now as this number has 6 digits, therefore it will have a root of 6 by 2 or 3 digits, right? Now as it will have 3 digits, there will be a hundreds place, a tens place, and a ones place. Now to find out the number or the digit that will be at the hundreds place of the root, we will have to compare this number with the table of squares. Now from there we can see that the perfect square nearest to 53 is 49, The perfect square nearest to 53 is 49, which is 7 square. So we put 7 here. Simple. Now what we have to do is we will have to subtract this number from this digit square. Okay, so we'll subtract 53 minus 7 square, which is equals to 53 minus 49, which is going to be 4. Okay, now the digit that you get, this will be placed alongside the leftmost digit of the second pair. So combining 4 with this, we get 47. We combine this digit and place it to the left of the left-handmost digit of the second pair. We place this to the left-hand side of the left-handmost digit of the second pair, and we form this number. That is going to be 47. We divide this number by this number into 2 plus 1, which is 7 into 2 plus 1, which is equals to 47 by 15. Now this gives us a quotient and a remainder. Our quotient is 3 and our remainder is 2. Now as our quotient is 3, we place this directly in the tens place of the root. The quotient that we find out after this operation will be placed directly in the tens place of the root. And as the last digit of the number whose square root we are finding out is 9, the last digit of the root can have two possibilities. It can either be 3 or it can be 7. In order to decide which one of these two digits will be placed in the ones place of the root, we will have to compare the quotient and the remainder. If the quotient is greater than the remainder, we choose the lesser of the choices, and if the quotient is less than the remainder, we choose the greater of the choices. Okay, here the quotient 3 is greater than 2, therefore the number or the digit that will be placed at the ones place of the root is going to be 3. As quotient is greater than the remainder, therefore we'll choose the lesser choice, that is 3, and it will be placed at the ones place of the root. Now let's do a recap of the entire process of finding out the square root of a perfect square which is greater than 40,000. We take the same number again. Suppose we are asked to find out the square root of 537289. This time I'll be a bit more faster. We'll split this up into pairs of 2 starting from the right. Okay, so here we have 3 pairs, 53, 72 and 89. As the number is of 6 digits, therefore the root will have 6 by 2, 3 digits, right? Therefore the root will have a hundreds place, a tens place and a ones place. In order to determine the digit that will be at the hundreds place of the root, we will have to compare this with the table of squares, where we can see that the perfect square nearest to 53 is 49, which is 7 square. Therefore we place 7 directly in the hundreds place of the root. We will subtract this from the square of the digit at the hundreds place. So 53 minus 7 square is equals to 53 minus 49, which is going to be 4. We place this digit to the left hand side of the left handmost digit of the second pair, and the number that we get is 47. We divide this number, that is 47, by the digit that we found at the hundreds place into 2 plus 1, which is going to be 47 by 15. It gives us a quotient and a remainder. Our quotient is 3 and our remainder is 2. As our quotient is 3, we place it directly in the tens place of the root. In order to find the digit which will be at the ones place of the root, we will have to compare the quotient and the remainder. Now, as the last digit of the number whose square root we are finding out is 9, therefore its root, the digit that the root ends with, can have two possibilities. It can either be 3 or it can be 7. Now, in order to choose it will be 3 or 7, we will have to compare the quotient and the remainder. If the quotient is greater than the remainder, we choose the lesser choice. If the quotient is less than the remainder, we choose the greater choice. Here the quotient is greater than the remainder, 3 is greater than 2, therefore we will choose the lesser of the choices, that is 3. Therefore 3 comes here and our square root is 733. That's it, my friends. So stay tuned and keep watching our videos on Aptitude series. We are sure it will help you.